Hey you guys, welcome back to the channel PHYSICSSIRJEE, and here we are in the Pathfinder solution series, and I have brought forward two problems from the chapter of Newton's laws of motion. Actually, they are related to each other, so it's hard to look at them in the first go. The face value of the questions, if you see on the pictures, the first one and second one don't seem to be related, but I would actually make you take a closer look towards them, and you'd see that they're related by a very important constraint that could be a candidate for JEE advanced examination. So let's move forward and look at the problem statements of each of these. One is from the build up your understanding section 20th problem, and second one is the check your understanding 5th problem. Okay, so first one, a ball of mass m is suspended from a bar of mass capital M with a light inextensible cord. The bar can slide on a frictionless slope of inclination theta. Initially, the bar is held motionless so that the ball also stays motionless as shown in the figure. Find the acceleration of the bar and the ball relative to the ground immediately after the bar is released. Acceleration due to gravity is g. Okay, we'll start off with the first question, which is pretty simple. Actually, most of the students, when they go with this particular question as a basic practice for constraint relations, should get this one. Okay, and then we'll see how that constraint can be used to solve the slightly challenging question, that is the fifth one. Okay, so let's move forward with the first one. You want to give it a try, pause, try it out and come back. Okay, so I've pre-written all the things that are required. You could see I borrowed the picture from the textbook already, and this is A2 acceleration of the bar, as he calls it, which is down the incline, and A1 would be in the downward direction. The reason I'm able to take these two in these two directions is that he asked immediately after. I can't do this once the motion over a period of time takes place. Okay, so that's one very important thing that you need to understand, that the thread remains vertical dt seconds later. So I've drawn the free body diagram, mg sine theta and t sine theta, right? So the tension also will have a component on this bar, and that's what I've drawn. I have not drawn any forces in the vertical direction because they would cancel out. And for the pendulum or the bob, that would have a tension t and mg in the downward direction. Okay, so I put the accelerations and the simple Newton's laws of motion, first one and the second one you write out. You realize that there are three variables: tension, acceleration and acceleration. So you need a third equation, which is obviously a constraint relation that the thread remains taut in the vertical direction, which is only possible if the end of the threads move with the same acceleration. Okay, so the a2 sine theta in this direction should be equal to a1. Actually, we should have written it for v1 and v2. Velocities are the constraint, but since initial velocities are 0, you differentiate this, you will end up having the acceleration version. Okay, so that's the reason why you are able to do this. If I had released them with some velocity, I cannot write a1 sine theta equal to a2 sine theta. So two important things that you have to take into account for being able to write this. So once you solve these, it's a child's play, and you'll end up getting a2 is down the incline like this, and a1 is just a factor of it by a sine theta, okay, in the up downward direction. Now for the next problem, I'll try to borrow, because in the next problem I'll have two objects which are of same mass. So just for fun, even though it's not the answer for this question, answer is this box, I'll try to substitute capital M and small m and get these expressions again. Okay, if the two masses that were given in the question were equal to each other, I would have ended up getting these two accelerations. So have a closer look at this second one, which I would borrow in the next question. Okay, 2g sine square theta by 1 plus sine square theta down the vertical. Okay, so now let's move forward and read the problem statement for the check your understanding question, the one with the helix and all. So a bead slides down a height h on a rigid thin vertical rod in time t1 and the same height of rigid helix in time t2. That means you have a bead which goes down and takes a time t1 here in the experiment number 1. In the experiment number 2, the same thing will go down a helical path, and height is the same from this to this picture, and the time taken is t2. Now the rod is rigidly fixed along the axis of the helix, and the bead that can slide on the helix is tied with a light inextensible thread to another identical bead that can slide on the rod as shown in the figure. So two beads are tied to each other, and one bead is supposed to move only along the vertical rod that's fixed, it seems, and the second one is supposed to slide along. So now these are constrained or connected type of motion that is going to happen. Okay, so like a combination of case 1 and case 2 is the case 3, and the thread is kept. Okay, so the assembly consists of the beads and the thread is released from rest. How long will this assembly take to slide down the same height h? Very important assumptions that he makes here is that neglecting friction and air resistance and assume radius of the helix is so small, this radius of helix is so small as compared to the length of the thread, that the thread can be assumed almost vertical. That is where we will bring this particular problem here. This thread that it seems like slant in the diagram is actually supposed to be assumed to be nearly vertical in our solution. Okay, you want to give it a try, you can pause the video, have a try. This is a very good question, and then we'll go ahead with the solution and the concept. Okay, right. So one primary thing that you need to know before we go forward is from one of my previous videos. I think this was one of my first or second videos I have done on my channel long time back. Okay, not so long time back. Okay, so this DL for a pitch of a helix problem, I think that was also from Pathfinder, and we solved for the pitch of the helix using physics intuition. Okay, so we have already proved that the angle of helix, which can be written either with vertical or horizontal, I have chosen the angle here with horizontal. What is angle of helix? Each and every DL element here, small DL, if I zoom it like this, okay, this DL forms a right angle triangle with a small height variation DH. The angle formed by this right angle triangle is theta, and at every place in the uniform helix that angle will be the same. Okay, right. And in that video we have already proven tan theta is the pitch divided by perimeter of the one single turn. That you can check, or you can write it as 2 pi r, but here I'll not be using that. So you can check that video, link is in the description below, for the insight and more elaborate explanation on how we measure this angle theta and all that. I'm taking it for granted. Okay, right. Sine theta is to be measured, that I think you can see that sine theta is dh divided by dl. Now each and every triangle that I can form obviously won't be in the same plane, but that triangle itself will keep rotating as I keep along the helix. So this sine theta equal to dh by dl, many such triangles I can write, then all the numerators can be added and all the denominators can be added, and you will end up getting simply height divided by the total length also will have the same angle sine theta. So I hope you understood how I got from dh by dl to h by l because of the identical and uniform nature of the helix. So please remember, this theta is like, you can think that any bead that goes on this one feels like it is on an inclined plane of angle of inclination theta at that particular instant. Okay, so the tangential acceleration here would be related to what it would have been on an inclined plane. This is the very important crux of the understanding. Okay, so now we'll go back to the question, and in the question I've enlarged the picture for you. The leftmost case 1, the height h has been covered in time t1, and in the second case the same height but obviously different perimeter, it covers it in t2, and if he wants you to express the final answer of t3 in terms of t1 and t2. So let me first write the expression here of t1 in terms of h. It's a pretty basic fall under gravity kind of situation in the absence of friction. T1 is root 2h by g. So 2h, I'll write it appropriately as gt1 square. Keep it aside. And when in the second experiment, I told you already that this particular bead will feel as if it's on an inclined plane of angle of inclination theta. So what's the tangential acceleration at every instant that it will feel? G sine theta. And if the perimeter that it covers is, let's say, length L, the total length L, then the time duration would be, obviously here h will be replaced with L and g would be replaced with g sine theta. But we also know that in the previous slide I told you that the value of sine theta can be written in terms of L and h. It's nothing but sine theta is equal to, what did we get there? Sine theta was equal to h divided by L, or you can replace L with h sine theta. So then, sorry, h by sine theta, L is equal to h by sine theta. So you end up having root 2h by g with sine theta out. So can I say T2 value is therefore equal to T1 divided by sine theta with sine theta coming out? I think this is not very difficult for you to understand. So from the first two calculations, I ended up getting two equations which I would use in the third one. Now, I would say this particular problem is equivalent to a bob moving on an inclined plane with a vertical thread connected to another bob which is supposed to move only vertically. I think at every instant dt seconds, it feels like this problem is equivalent to a small inclined plane at that place, with this one representing this particular bob and this one representing this bob, and this is equivalent to that previous build up your understanding question we did. So I'll borrow the answer for that. A1 that I wrote is 2g sine square theta by 1 plus sine square theta for equal masses. And therefore this time this bob will have to fall through the same height h with acceleration a1 and not g. So the time t3 should be this number. I'll take t3 square, and the top 2h I'll replace it with gt1 square. Can you see the green replacement here? And for a1 this entire red thing I substituted there. Okay, right? And you just flip this one onto the top, g's get cancelled, and you'll get t1 square by 2 outside, and 1 plus sine square theta divided by sine square theta. I wrote it in this format. So the last thing that is left out is to substitute for 1 by sine square theta, which is t2 square by t1 square. You can see that blue thing has been substituted here. Okay, and you rearrange, you will end up getting a simple looking arithmetic progression for t1 square, t3 square, and t2 square. So the value of t3 nicely comes out to be a simple looking expression, which is the answer given in the textbook. Okay, so I hope you have loved this way of relating the helix with the previous inclined plane constraint. And the helical properties are very important when it comes to JEE Advanced, because this forms a very important figure for your magnetic field topics later. And in case you are already 12th students, you do understand what I'm talking about. So all these things can be formed into a very simple comprehension for JEE Advanced. So it would be very good if you can go back and look at the video that I was talking about. The link is in the description for the helical properties that I described. Okay, so I'll be posting more and more Pathfinder solutions, especially for the next 15 days. I'll choose only those questions which are relevant for JEE Advanced examination. Okay, right? I have done many of them already, so you can check the playlist link in the description below. Except one or two, most of them are related to JEE Advanced. I try to choose as many as possible. Apart from that, whatever series that I'm going to come up with in the next 15-20 days, keeping in mind JEE Advanced exam, even in Olympiad workout or AITS select or resolve, I'll try to keep the concepts as close as possible to only the JEE Advanced level, not less, not more. Okay, so all the links of the playlists are in the link description below. So try to surf through them, and try to like, share, and subscribe to my channel, and try to hit the notification bell icon so that you end up getting the notification whenever I keep posting the videos, which I would like to do it as frequently as possible. I am actually quite sorry that I couldn't, because I was pretty busy with my students. I'll be still busy, but I'll try to find as much time as possible. Okay, right? Thank you. See you in the next video.